So today is, the data is growing like crazy. We get so much data all over internally and externally, mostly external data sources. So how do you analyze this big data? So we are going to take the social equity problem and see how can we apply it to and show you in the context of data science methodology, what's the process of analyzing the data. So before we begin, Arvind, would you like to introduce yourself?
You want to introduce the topic first?
Okay, so I think this is a topic like everybody's familiar with. We are all connected through LinkedIn. So how do we analyze our LinkedIn data to see how well we are connected with so many people we have, what kind of people those are, what kind of gender they have, are we biased to certain type of gender in our communication in the LinkedIn? So that's really how do we use the LinkedIn data to analyze our connections. And we will talk more about the problem as we go further. And then we will introduce the data science methodology. And then we will demonstrate the methodology on the gender equity assessment on the data from the LinkedIn. And then we will have some open discussion where we can talk about, anybody can ask any questions. So let's start with the introduction first. Let's introduce quickly ourselves.
Yeah, actually moderators did a pretty good job, so we'll do a
very
quick job of.
So let me start myself. I am Nina Sathi, and as he said, I definitely have more than 30 years of experience in AI development. I started my career with an AI company, AI startup called Carney Group, where we built a lot of systems for Quest, for digital equipment, for US Army, and basically those systems are still in use. And then those systems, as I said, were deployed in telecom, healthcare, retail, and of course, in the US Army government area. And these applications, AI applications, range anywhere from customer care to back office automation to conversational AI chatbot to graph analytics, and they have been deployed worldwide in North America, Southern America, Asia, and Europe. I have many publications in AAAI, IEEE, Word of Watson, and you name it. And as our presenter also introduced, I had worked in the capacity of Director of Knowledge-Based Systems at Accenture, CenturyLink, KPMG, IBM. After my initial 7 years with AI startup, I have worked with leading companies in US. Currently, I'm a principal at Applied AI Institute. Here is my contact information if anybody would like to connect with me on the LinkedIn or check out my courses or details through YouTube videos. Arvind, would you like to go next?
Yeah, what you will notice here is that we are married to each other and we have very similar backgrounds. I've got minor differences from Nina, but not necessarily a lot. I got a PhD in AI from Carnegie Mellon University. One of the fortunate things that I got out of that was I had a chance to work with Nobel Prize winner Dr. Herb Simon, who started the field of AI. And it was a good chance to learn right from the masters in this area. I currently work on AI literacy at KPMG. I lead a course catalog that we have created with a lot of third parties. And we use that to teach AI advisory consultants concepts of data analytics, AI, and so on and so forth. Very similar to Nina, I've got similar kind of work experience, telecom, media, and accounting. And I've done a lot of work in Asia, for example. I did a lot of work in India, in Australia, in Europe, and of course, back in the US. I've got 4 books. I'm going to give you here a link to my books. They're available through Amazon. And feel free to connect with me on my either email or through LinkedIn.
So let's talk about what we would like to use an application for demonstrating our data science methodology. What do you mean by equity in communication, Arvind? Would you like to talk? What is your problem?
Yeah, let me talk a little bit about the problem I have. Um, Nina, remember you gave for Analytics Vidhya a webinar about 2 months ago.
Yeah, in September.
Yeah, in September. And what was interesting about it was that I took that webinar information and I posted it on my LinkedIn. I have a habit of posting anything that I find from KPMG that is worth sharing with outsiders. For example, KPMG jobs, for example, webinar like your webinar with Analytics Vidhya. And on an average, I get somewhere between 800 to 1,200 impressions out of those posts that I do. It's quite a popular page I have. I have over 3,000 connections. Now, I'm a little worried that I may be creating the equivalent of the men's locker room problem, which is I may have a lot of my connections, which are all men. Now, that is a problem because if all the information I'm disseminating is biased towards male audience, then that does not really give a wider distribution. There are lots of very, very talented women data scientists, and I definitely would like to share with all of them. So the key question I'm asking is my connection gender biased?
Why is that so important to you to see whether you are gender neutral or not?
Well, the important thing about communication is that the communication should be going across to everybody. And there are important communications that KPMG is making, for example, publishing new hiring opportunities, which I definitely share on my social media. And KPMG has a very important ESG initiative right now in place where they would like to make sure that a lot of their communication remains gender neutral.
Okay. That's interesting and very impressive that you are looking into ESG initiative to make sure things are gender neutral. And so let's do this way. Before we get into this problem, let's start with data science methodology, because we have defined a methodology after so many years of experience, and this methodology has been applied in many applications. So I would like to quickly introduce the data science methodology, and then we will apply that methodology in the gender equity problem using your LinkedIn data and see how we can apply that. So let's start with why a methodology is very important. And you know that in the last 20 years, the data has exploded like crazy. There are 4 V's, I call it 4 V's of the data. And these V's stands for, there is a big, huge volume. My CIO of the previous company used to say that the data really triples every 4 years, because there's so much data, volume of the data these days coming from chats, logs, internet, videos, and you name it, websites. So the volume is really how big the data is. Velocity, how frequently this data is changing, because sometimes now these days we are providing real-time promotions, real-time advertisement delivery, how fast this data is changing. Can I deploy it on an edge device and deliver it in a real time? So what is the velocity change in the data? Variety, how different types of data we have. We have different types of data. You have a structured data, which is coming from your relational tables. You have a semi-structured data coming from Excel spreadsheets and so on. And then you have a unstructured data, which is coming from videos, audios, chat logs, internet, you name it. So what's the different variety of data do you have for your analysis? And veracity, how authentic your data sources are. Are they really reliable data sources? Like census site is a very reliable, because that's very reliable source of data. But then you can also have a fake data these days. WhatsApp, and if you see all these social connections, they are also bombarded with fake videos. So how reliable your data sources? So those are the 4 V's. And since the volume, velocity, variety, and veracity is changing so often, that is really important to see how often can be analyzed. And let's look at the So what was there any methodology already in place, and how did we modify it? So in 1996, IBM acquired SPSS, and that SPSS came with a methodology called CRISP. CRISP-DM stands for Cross Industry Standard Process for Data Mining. And that was the de facto standard in 1996. And it started with defining a business problem to data understanding, and then finally you deploy. And that was mostly meant for BI application. You have business intelligence. How do we apply you for a BI application? How do we analyze the data and publish the reports and deploy those reports, or any visualization which goes with that? So that was the standard in 1996. With the introduction of AI, with the introduction of machine learning, with the introduction of adaptive learning and so many new things, this methodology needs a evolution. And why do we need evolution? Because earlier in the 1996 and 90s, we basically were looking at the sample and then analyzing the sample and then projecting that how that will go for the full population. So that used to be the trend, using the sample analysis. Now we are getting more into micro analysis. We want to get into each individual and say, how do we analyze this individual? How can we know more about this? What is a 360 degree of this particular Arvind Sathi or Nina Sathi or anybody you name it? So we are looking at micro analysis on sample. We also have a lot of external data these days coming, especially coming from the social media, from internet sites, government regulations, chatbots, I mean, you name it, which are coming. And then we are using this data and deploying them through a scoring engine real time. We have a lot of diverse set of techniques. You already heard me in the graph techniques last time. We have a lot of machine learning, regression, forecasting, time series analysis, graph, you name it. And then you have AutoML techniques, which can look into many diverse techniques and give you the best techniques to apply. And then there is a notion of adaptive learning. How do we modify our model based on the feedback, based on the learning from the deployment? And of course, how do you govern the process of feedback so that there are no biases? So all of those things needs to be incorporated in the data science methodology. So as I said, the CRISP-DM was introduced in 1996 for data mining. And then IBM introduced a few years ago something called AssumeDM, which stands for Analytics Solution Unified Method. And that was really for AI, like how do we incorporate AI, which is more of iterative development and analyze, design, build, then deploy. So it's more of iterative development. And so what we did, we took CRISP-DM, we took the AssumeDM, and then we created a 7-step process for data mining, for data science projects, anywhere from defining a project to understanding your data, preparing your data so that you have a huge amount of data, can we condense it, synthesize it, and utilize it effectively in our data modeling. And then, of course, after that, you develop your model, evaluate your model, how effective your model is, and then you deploy it. And then based on the deployment, you look at the feedbacks, look at how model is behaving in the production setting, and then you optimize your model. So those are my 7 steps of data science methodology. And we will apply at least first 4 in your LinkedIn data connection problem. And you can see it. So starting with this define project, describing the data, preparing the data, developing the model. And of course, it's not just like that when you optimize it. You might have to go back based on the optimization. You might have to go back, refine your model, then evaluate, then change the deployment again. Or you can, you might have a need for a new data, or you might have a need for or your use case got changed, and you might have a need for getting the new data set. So there is always, you have to go back to the previous steps and make sure that if your business problem changes, you change the data and prepare it. So those are the 7 steps. So let's look at the business equity problem in the context of these 7 steps. So Arvind, let me quickly summarize the defined project, and then I will ask Arvind for the data. So in the defined project, there are 4 things we are really interested in. Who are your user for which you are targeting this problem? What are their needs? What are their requirements? What kind of benefits they will get from solving that problem? What are the goals for the project? And what are the success criteria? How do you define the success? And what are the steps you will follow to develop the project? So in this case, I believe, Arvind, you are the LinkedIn user who are interested in information sharing, and you are concerned about gender equity within your LinkedIn data. And basically you want to find what is the gender distribution, how many male versus female do you have in your connections. And that will give you a better idea in the information sharing, what kind of information you should share. And then what are the success criteria? Would you like to talk about, are these the right success criteria?
Yeah, so firstly, the user persona is important because what you're really doing through that process is personalizing the problem as opposed to making it a very general thing. And now you can really talk about the benefits that I get out of it. Now we have to make the criteria a little bit more specific, because otherwise we could be there forever. There are lots of nuances in the LinkedIn connections I have. My connections do have special names that I may or may not be able to easily find anywhere in any of the reference databases. There could be unknown names. So the key question is, can we time box it? So long as we get about 85% of the connections right, we should stop at that point in time as opposed to going after a perfect 100% score.
That makes sense.
And then that is one of the key things. Now, the other thing is that we do need to put that into a defined format where we go and do each of these steps: define project, describe data, prepare data, develop model. Given that we have only 1 hour available right now, we are not going to do any evaluate model, deploy model, and optimize model. But of course, if we were doing the real project, we would do a lot of those steps also. Last but not the least, I would like to make sure that there is a sandbox that we use. In this case, we are using Dataiku as our sandbox, and we're going to show the model and dashboard in that sandbox.
Sounds good. So we already covered the step 1, define project, which has all these 4 major characteristics. So let's move to the describe data. What kind of data do you have?
So let's talk a little bit about the sandbox. What we are using is a product called Dataiku. One of the reasons why we both like Dataiku is that it is probably the best product that represents our 7 steps of the methodology. We find that a lot of tools do a very good job of develop model, but then they stop there and they don't do a very good job of deploy part of it, or they don't do very good on optimize the model. This is one of those rare products that does hit all the 7 steps, and it has got significant capabilities in, for example, in design, development, and deployment of machine learning models. It also provides a lot of ML ops capabilities, which are getting quite popular in terms of how you deploy and optimize a model. So all the work that we did here was using Dataiku Sandbox. We have a sandbox available for academic work, and if you're interested in utilizing that sandbox for learning, we can definitely help you in that situation.
So let's go to the describe data. Can you show a little bit more about how do you collect the data and describe your data, or how will you classify your data?
Okay, so let's look at the LinkedIn data, and also let's look at the data from one of the reference sources. So let me go to the LinkedIn data first. Now, what I've done here is to do a screenshots of how I pulled my data from my LinkedIn page. I went to my profile. There is on the top right corner, you will see a profile picture. When you click that, you're going to be able to get to a menu which has got settings and privacy as one of the areas. You can go there, and from there, you can go into data privacy, get a copy of your data. And for the purpose of this analysis, I'm going to say just go ahead and click very specific data, which is your connections and request and archive. Now, for those of you who are online, if you want to try it right now, go into your LinkedIn and go through the steps. In about 10 minutes, you will get an email which would have a link to all your connections. The second thing that I would like to introduce here is the gender by name data set. So this is a data set I got from UCI Machine Learning Library. And this is a data about 145,000 names. They mined this data from, this was an interesting piece of work that somebody from University of California, Berkeley did, where they mined the data from birth certificates from US, Canada, UK, and a couple of other spots. And they basically pulled all this data, about 145,000 birth records. And in the birth record, it has got a gender identification. So based on that, we now know, for example, Arvind is predominantly a man's name, Nina is a woman's name. And for example, a gender neutral name like Sandy is probably 50-50. And that kind of information is available in this database. So for each of the 145,000 entries, the machine learning database that we have has got a probability of distribution on that name being a man or a woman. So utilizing that LinkedIn data, I looked at all the data that I had, and I found some very interesting things about this data. This is, by the way, very important from a described data perspective, because we should be, before we go and do any analysis, we should be looking at the data and finding out if there are any things worrying us about the data. Firstly, that there are 72 values where there's no value. I didn't expect LinkedIn to have that, but apparently out of the 3,425 entries I have, there are 72 of them that do not have a first name. As you may easily expect, David is the most common first name I have in my collection, with 45 entries, and then John, and David and John actually have a tie, and then you got Michael and Chris and Mark. So it is kind of a typical North American male database from the high frequency perspective. And then from there onwards, you go on to other names. Now, as you can see, the top 10 names or so here are all male names. So that is what I was really talking about.
So now let's move to we know the data, what we have. Now let's move to the third step, prepare data. What do we mean by prepare data? We have so much data about the LinkedIn connection. How can I reduce it to a meaningful set which I can utilize it for gender equity assessment problem? Or can we create a new feature which are more important for my building the model? Or can we synthesize the data? So those are the tasks needed in the prepare data, which is the step 3 of our methodology. So here is the LinkedIn data.
Okay, so one of the main things that we discuss about any data science is feature engineering. Most people think that data science is all about applying sophisticated statistical techniques. Let me tell you, in most cases, the statistical techniques are important, but they're not necessarily the life and blood of data science project that you do. It is feature engineering. If you provide the right feature, it's a possibility that with very, very simple mechanisms, you can actually get some really meaningful connections out of that. And LinkedIn connections, this is really where the feature engineering is going to fly in the biggest way. Firstly, I've got a very important column, which is connected on. So connected on is in the format of a date, month, and a year. And it basically tells me whoever made connections with me, what was the date on which they made the connection. Except that when LinkedIn gives you the data, Dataiku thinks it's a string, and we have to convert that into a date format so that we can do a temporal analysis of the data. Secondly, we have first names, and we have the first name where some of them are capitalized, some of them are not. So it will be a good idea to keep everything in lowercase, because the name gender database that I have is also lowercase. So connecting it and creating a lowercase out of that is important, because that's how we can now compare the two. And last but not the least, there are lots of names, where people have used more than one word to describe the first name. The name gender database that I have is all one words. So if I have a name and I'm going to pick a name from my LinkedIn connection, Priya Ranjan, which is a 2-word name, then I cannot find that kind of a name in my database. So I have to break it into 2 pieces that it has. Or for that matter, if somebody puts a doctor in front of their name, then I need to remove the doctor out of that. So this is where we have to do a little bit of splitting. And again, this is part of the feature engineering. You have to take the column information you have, and you have to reduce it down to the features that you care about. And in this case, the feature happens to be the first name with multiple columns, and we will look at any of the columns that match with any of the gender name gender data that we have.
So now let's move to the 4th step, which is more interesting. How do we develop the model? And again, here we need to talk about what kind of model we are building. Is it regression, time series forecasting, graph model, or you name it. Now, this is really a sort of a classification model. So how do we set up my classification, whether the person is a male or a female? How do we set up the classification? How do we classify it? So let's walk through those steps.
Okay. And in this case, it just so happens that the classification turns out to be just matching the name to the name gender database. As I promised to you earlier, feature engineering is what made it easier. So we essentially took the name from our name gender probability, and we matched to the first name that we had in our LinkedIn connections. And through that process, we find that there are 419 connections we could not connect to. There are obviously a lot of names in my LinkedIn connections. Many of them are ethnic names, which I'm not supposed to find in a typical name gender database. So it just so happens that 419 names are some of those special cases. For the rest of them, the mean turns out to be 0.25, which means 25% of the connections I have are women, and 75% of my connections are men. So, in this case, it's a pretty biased connection. So all the LinkedIn information that I'm sending about your webinars is actually not reaching my female audience. Okay, so with that, let's actually step a little bit into the Dataiku and show you. I was using screenshots to show you so far. I'm going to go into and step through this entire project one more time in Dataiku so you can see what we did there. And what I'm going to do is I'm going to get out of here and get into Dataiku so you can see the work there. So LinkedIn Analytics, this is a project that I've set it up in Dataiku. And associated with that, there is a flow. So we can take any of the data sets that we have in this particular case. For example, I have pulled the data sets for all my family. Everybody was here for Thanksgiving, and I was doing LinkedIn analysis for everybody. So this is what I have in my data sets. And I took my own connections, which is this data set here, and I used and what Dataiku calls as recipes. So what is interesting about some of these visual programming techniques is that in the old times, we used to do a lot of Python coding to do this kind of work. In the case of these tools, they provide you with visual recipes that let you do the same work with the click of the button on a couple of parameters that you specify here. So for example, if you have to parse the date, you can go into a recipe called parse date, given a column that you would like to parse it on, and then you can specify the format in which the data is currently there, what date format you want to use, and you have got here something which is a parse date. So that's basically how the setup has been done in terms of the recipes that we create in Dataiku, and then at the end of it, we can run it. We can look at the data that comes out of it. And now we got the prepared data out of it. The next thing that we do here is a join. So this is where we are merging the data from the name, gender, probability. So let me actually take you through this data set a little bit also and give you a feel for what the name, gender data set is. And this is a very interesting data set. What it contains is 145,000 names. And as you can see, some of these names are fairly unique. So you do have lots of 1s and 0s, which means there is only a single Abigail and Abish and so on and so forth. But then you also find a lot of common names here. So let me kind of move forward and I can show you some of the more common names. Lots of AAs, as you can see, that this is really a very rich database. So if I were to look at Isa, that's a 627 names I have, and all of them are females. Let's look at another one. That would be interesting. These are still very uncommon names. Very interesting. People have first name Apple, and there are 395 people with that name. So you can get an idea that this is a pretty extensive database, and you're going to find a lot of names that come into the name, gender, property. So in the flow, what we have here is a join. You can do many kind of join. You can do a right join, a left join, or an inner join, or an outer join, depending on what you do. It takes either the left part of its table or the right part of the table, and it combines them. In this case, I did the right join, so I'm connecting all of my LinkedIn connections to anything that I can match on the name, gender, probability. And from there, I'm taking certain selected columns, which are the name, female, male, and probability from the name, gender, probability, and the first name from the connections. And at the end of it, when I run it, I have a result coming out of that. That is a joint table. And in this table, I have a bunch of names. So as you can easily expect, a name like Dinesh is a very good likelihood of male name, while Poonam happens to be a fairly strong female name. I did not know, but there are 5 men with the name Poonam, which is interesting. Or for that matter, Vishal, which is a very male name. Timothy, which is a male name. Of course, it's interesting to see that there are still some number of women with name like Timothy. So you get an idea that we have now a lot of these names, and for each of them, there's a probability. And if I were to chart it, I can actually look at my data now, and I can start all the way from 2006 when I started using LinkedIn to today on the percentage of females I had. Now, what is interesting about my own history is that 2008 to 2016 was a time period in which, or rather 2018 was when I was working for IBM. And then I came working for KPMG. And before that, I was working for KPMG. So one of the things I feel good about KPMG is that, as you can see from my own data here, is the years in which I worked for KPMG, I've got more women in my connection than when I was working for IBM. It is a characteristic of a company that cares about these kind of social justice issues. Anyway, so that's basically the presentation on Dataiku itself. And with that, we can now go back to open discussion on any of these topics.
So let's start with the very first. Does everybody okay in getting the LinkedIn data? I just wanted to make sure that we can trade or demonstrate how to get the LinkedIn data, your own connection data.
There are some chats in the conversation. Is anybody? Okay, so it looks like Abraham is saying, kindly demonstrate again. I'm going to go into my LinkedIn page. So let's finish the poll, and then after that, I'm going to go ahead and show you how to get the data from your LinkedIn page. So it looks like we have 58% of the people coming from Asia. It's the largest contingent of people. Looks like nobody is rating the speaker yet.
I think so. The first question is, how do we get the data from LinkedIn?
Okay,
so let's
I'm
go
going
over
to,
that.
yeah, I'm going to go to the LinkedIn to show you how to do that. So here's my LinkedIn page. And here you see my picture, me. And I'm going to click setting and privacy. I go to data privacy, get a copy of your data, export your data, and I want something in particular, which is my connections, and I'm going to request archive. I hope that gives you a quick demonstration on how you go about doing that. Maybe you may like to try doing it right now and see if it works for you.
It is a few-minute process because it will be, the data will be coming in email to you.
Yeah, in about 10 minutes, you'll have the data with you.
So Arvind, do you want to go over your GitHub repository now to show the connection state?
Actually, what I would prefer to do would be to also show how do you get a data IQ.
Okay.
So Nina, can you tell a little bit about the course that you have?
Okay, so I do have a data course. Actually, I do have two courses. One is the one since we use data IQ in this example. So I have a course called Data Science Methodology in Action using Data IQ, and that goes step by step and explains all these 7 steps. And we use COVID as an example problem to demonstrate how do you get the data, how do you analyze it, how do you develop models, evaluate your model, and then deploy the model. So that course is available to you at a discounted rate. The discount promotion is valid until January 5th of 2023 for a month. So feel free to use this coupon to get detailed understanding on how do you build the models using Data IQ. That course does tell you how to set up the environment also. So how do you get the Data IQ? And if you have any questions, feel free to give me, send me an email at nsathi@aaii.ai. In case you have a need to know Python, I have the similar course in Python also. It's called Data Science Methodology in Action using Python. And if you are interested in Python, please send me an email and I will get you the discounted rate for my that course also. But Data IQ is the upcoming AI tool, so I thought that you guys will be interested in using it. Really hides a lot of programming techniques you need in Python because it's just point and click.
So, ma'am, we have a question from the Murugandas. So, what is the tool you are using? What are the charges? So, he is asking about the tools which we are using in the demonstration.
Okay, so the Data IQ, we can get you a free license for the Data IQ, and you can load it on your laptop for free of cost. The download.
Yeah, that is the community edition. So for the purpose of learning, you can use it in your environment. And in the course that we have, we actually give you step-by-step direction on how to load the community edition and work with that. For your corporation, there is a fee associated with Data IQ. So once you get past the learning, if you're interested in using Data IQ for actual work, you'll have to connect with Data IQ sales team and get access to that.
Yeah, for individual participants, you can download the community edition for free of cost and work on it. Okay, so I think the next thing I would like Arvind to do is to demonstrate how to get from you.
So I think what I have done here is to provide access to the Data IQ project. I can go a little bit more into the details of that, or alternatively, we can essentially stop the webinar at this stage.
Thank you very much. Thanks for coming and listening to our webinar. We truly appreciate it. Have a wonderful day. Bye.